Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 9-5, comparing functions. Alright guys, so we're going to compare constant change and constant percent change. Suppose you're offered a job that pays $1,000 for the first month with a raise every month after that. You can choose a $100 raise or a 10% raise. Which option would you choose? What if the raises were 8%, 6%, or 4%? Okay, so for off the bat, if we were doing the $100 raise, we would have $1,000, initially, and then after 1 month of working, then we'd start making $1,100 a month, then $1,200 a month, then $1,300 a month, right? We're going up $100 a month. Now, if we were increasing by 10%, 1,000 times 1.1, right? 110% as a decimal is 1.1. You move 2 places away from the percent sign and drop the percent sign. We get 1,100 times 1.1. We get 1,210. So you're already making more money that way. Times 1.1. Now you're making 1,331. So that 10% salary increase is definitely better than a $100 a month increase. What if it was only 8%? Well, we would have 1,000 times 1.08, right? We would have 1,080 times 1.08, 1166.40 times 1.08, 1259.71 times 1.08, 1360.49 times 1.08, 1469.33 1586.87 1713.82. So it takes until 7 months to start making more at that 8% increase. So you're going to make more eventually. It's just going to take some time. What about 6%? 1.06. 1060 times 1.06. All right, so now let's think. If I'm going up 6% each time, if I'm making, say, $2,000, so and I'm multiplying that by 6%, that'd be a $120 raise. Once you hit like 2,000, then you're getting a $120 raise. Where here, you're only getting a $100 raise each time, no matter what. So eventually, say I have 4,000, right, times 0.04. That'd be 160. So eventually, if you plan on working there forever, these will eventually make more money than the $100 flat rate, but it's going to take time. Does that make sense? So 1040 times 1.04 right, so it's going to keep going on forever, but like I said, say you get to $4,000 a month, right? Well, 4,000 times 0.04 is $160 raise going on from there. So since it's growing exponentially, eventually you're going to be making more than $100 per month raise if you go with those percentages. Which percentage would be the best? Obviously 10% is going to get you there faster than 4%. So it really boils down to how long you plan on working there. If you plan on this just being a summer job and you're only going to work there for 3 months, then it's going to make the most sense to go with the 10%. Say even if you were only working for 2 months, it's still the 10% is a much better deal. But if you were only going to work for the summer, then you wouldn't want to go with your 8%, 6%, or 4% because the $100 flat increase or the 10% increase are both much better options than that. But if you think you're going to be working there for the next 20 years, then obviously any of those percentages is going to give you that nice higher pay than you would with the $100 raise each month. At first it sounds like, ooh, $100 a month, that's like a lot of money. But it's not as much as those percentages. A 4% raise after 30 years is going to be much higher than that $100 raise each month. Okay? Make sense? Alright, so looking down here, continue until you have the number of months it takes for each salary with a % raise to exceed that month's salary with a $100 raise. Record the number of months in the table below. Okay, so for the 10% raise, it takes 2 months. For the 8% raise, it took, we said 7 months, right? Did anyone figure out the 6%? Did you keep going? Well, it actually is going to end up taking 18 months. And then it's going to be 43 months. So we could actually put this into an equation to be able to solve this, right? So we have the percent increase is 1.08 to the how many times, right, to your number. And we started at 1,000. And we want it to be equal. Plus 100 of the x, right? This would be so much easier with a graphing calculator because you could just throw it both in here. But you could also just repeatedly, like they were saying, that you could just press enter repeatedly. So like if you were doing, like if I was doing 0.08, this is probably the fastest way. So 1,000 times times 1.08 equals 1080, right? That's 1. Oh, is it not going to let me just keep pressing enter? Not on this calculator. Of course not. Does your calculator let you guys? It does on the ones that we're not allowed to use. The ones that, you know, have more of a brain. So yeah, you can't just, like, because they're saying, oh, you just kept pressing enter. Yeah, no, it's not going to let you. You can do times 1.08. You could do this, 1.08 store 1, and then you could just do 1,000 times recall 1 equals times recall 1 equals times recall 1 equals times recall 1 equals, and just keep track of how many times you push the button. But that's not as easy as just enter, 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 enter to see until you get to the same number. Yeah, sorry guys. Because you know that the numbers are going to be easy to know because they're going to be like 1100, 1200, 1300, 1400, 1500, 1600, 1700, and so on. So once you get one of those perfect even hundreds, you know that you got to where they're going to break even, to a break even point. Yeah. Yeah. What is the change per unit interval in monthly salaries for each option? Which of these is a constant rate of change in dollars per month? So your constant rate of change in dollars per month is the $100 per month, right? Going up $100 every single month is going to be that constant rate of change. What is the change per unit interval in the monthly salary in each option? So you had $100 per month, 10%, 8%, 6%, 4% per month. So which one is the constant rate of change? That's the $100 per month. With percent change, it's not constant. The raise increases each month. It's not a constant raise, right? Why are the differences from row to row in each percent column not constant? What is constant about the changes from row to row? All right, so each raise is a constant multiple, or percent, of the previous salary, but because the salaries are increasing, the product gets bigger with each raise. What is constant is the percent of change. Comparing linear and exponential functions. Compare these two salary plans. Job A is $1,000 for the first month with a $100 raise every month thereafter. Job B, $1,000 per month with a 1% raise every month thereafter. Will job B ever have a higher monthly salary than job A? Eventually, right? It'll take forever, but eventually. So, job A, S of T, right? They're going to be $1,000 plus 100 times T. Where the other guy is $1,000 times 1.01 times T. This one's exponential. This one's linear. So if we were going to use a graphing calculator to sketch these out, one of them is going like this, it's linear, or the other guy is going to go and eventually be better. Will job B ever have a higher monthly salary than job A? If so, how many months will this happen? Explain your reasoning. So yes, that's going to be in 364 months. You would know this because you would plot these two equations into your graphing calculator if you had one. And then it literally will tell you the point right here that they intersect. At that point, the graph of S of A T rises, S of B, sorry, BT, rises above the graph of S of A, T. Revise S sub BT and use the table feature on your graphing calculator to find the interval in which the monthly salary for B finally exceeds that for A. If the growth rate is 0.01%, use intervals of 1,000. Repeat for the growth rate of 0.01 using intervals of 10,000. So basically, with this stuff, guys, they're expecting you to actually use a graphing calculator, which you guys don't have. So we're going to ignore this. The table shows monthly salary functions for 4-month intervals rather than 1-month intervals. Does it grow equally? Differences over 4-month interval. Explain your reasoning. So on here, how does S sub A of T grow by equal differences over a 4-month interval? Explain your reasoning. Going up 400, 400, 400, 400, 400, right? Isn't it increasing 400 each time? Does S sub A of T grow by the same difference over the first 8-month interval as it does over the first 4-month interval? No. It grows 800, right? Over 8 months. Does S sub BT grow by equal factors over each 4-month interval? Explain your reasoning. What do you guys think? 1040.6 divided by 1,000, I get 1.0406 times that one. That works, times 1.04, right? 1082.86 times 1.04. I mean, my change is slightly off because I had to put that part in. But yeah, pretty much. So, yes, the growth factor is just over 1.04 for each 4-month interval. Does S sub B of T grow by the same factor over the first 8-month interval as it does over the first 4-month interval? Explain your reasoning. So over 8 months, it would be 1082.86 divided by 1,000. I got 1.08, right? That's going to be a no. The growth over 8 months is 1.08, not 1.04. Does that make sense, guys? Let's get some of this practice done. However, each quantity is changing at a constant rate per unit of time, at a constant percent rate per unit of time, or neither. Amy's salary is $40,000 in her first year with a $2,000 raise every year thereafter. So she's going to have like $40,000 thousand, and then after 1 year, she's going to have 42,000, then 44,000, and so on. So what's going on here? Is this going to be a constant rate per unit of time, a constant percent rate per unit of time, or neither? What do you guys think? Constant rate. Going up 2,000 per year. Carla's salary is 50,000 in her first year on the job, plus 1% commission of all sales. What do you guys think? Constant rate, constant percent rate, or neither? It's neither. Anyone know why it's neither? This isn't a raise. This is commission. She's making 1% of her sales. Her sales might be good 1 year and not as great the next year and then fabulous the following year. She's not getting a raise. She's getting a commission. She's making 1% of the total sales. The sales are going to go up. They're going to go down. They're going to be all over the place, right? So that's not going to be a constant percent increase or a constant rate increase. It's going to be neither. Enrollment at a school is 976 students initially, and then it declines 2.5% each year thereafter. Constant percent rate, or neither. I heard one person. Constant percent. Companies X and Y each have 50 employees. If Company X increases its workforce by 2 employees per month, and Company Y increases its workforce by 2% per month, will Company Y ever have more employees than Company X? If so, when? All right, so we have Company X and we have Company Y. Okay, so 50 employees. Company X increases by 2 per month. Okay. Company Y increases by 2% per month. 50 times 0.02, they're going up 1 person, so they're at 51. 51 times 1.02, 52 times 1.02, 53 times 1.02, 54 times 1.02, 55 times 1.02, 56 times 1.02, 57 times 1.02, 58, I guess that's actually like 59, times 1.02, 60 times 1.02, You see how annoying this is when you don't have a graphing calculator? What is this? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65. And 64 is the break here, and 65 they go ahead. So, we are on number 4. Yes, in 65 months. And that is how you would do it without a graphing calculator. Oh yeah, it's really fun, really fun. All right. Doable? Yes. Annoying? Yes, very much so. Centerville and Easton each have 2,500 residents. Centerville's population decreases by 80 people per year, and Easton's population decreases by 3% per year. Will Centerville ever have a greater population than Easton? If so, when? Explain your reasoning. So once again, you would just do the chart and figure it out, and this one is going to be no. Centerville's population decreases by 80 each year, while Easton's population decreases by 75 the first year and by smaller amounts each year thereafter. So Easton will always have the greater population. Complete each statement with the correct function from the table at the right. Blank grows at a constant rate per unit interval. Who's growing at a constant rate? Plus 4, plus 4, plus, not plus 4, not plus 4. So it's not f of x. Let's look. Plus 4, plus 4, plus 4, plus 4, plus 4. g of x. Grows at a constant percent rate. Let's see. 54 divided by 50 is 1.08. 54 times 1.08, 58 times 1.08, 63 times 1.08, 68 times 1.08, 73. This is times 1.08. Each equation for the linear, an equation for the linear function is as follows. The one that's linear is this one. So you have 100 is your y-intercept, and it's 4x, right? Y equals 4x plus 100, 4 times each one, right? Where the other one, and that y is the same thing as g of x, right? G of x or y. The other one is f of x equals, and what is that one going to be? It's going to be 50, my initial number, 1.08 to the term number. Okay, exponential. Linear, exponential. And this is just more of the same. So I think that you guys are okay. So your homework tonight is going to be page 539 and page 540. All right, so you guys are doing page 539 and 540. You're also doing the textbook chapter review on page 674, numbers 1 through 16 all. Check all of your answers on Edmodo and study because you guys have your chapter 9 test tomorrow. I hope you guys enjoyed this lesson on 9.5. Please like and subscribe and have a fantastic day.